Rule number 2. To find the partial fractions of f of x by g of x when g of x contains repeated and or non-repeated linear factors. Now let us have a discussion on rule number 2. So in this case, let f of x by g of x be a proper fraction to each factor ax plus b whole to the power of n. A does not equal to 0, where n belongs to positive integer z plus of g of x. There will be partial fractions of the form a1 by ax plus b plus a2 by ax plus b whole square and plus and so on an by ax plus b whole to the power of n, where a1, a2, a3, so on an are constants to be determined. Now let us solve the problems on rule number 2. First problem. Resolve x square plus 5x plus 7 by x minus 3 whole cube into partial fractions. So now here x minus 3 is the linear factor, but x minus 3 whole cube means linear factor is repeated for 3 times. So rule number does not applicable for this problem. So whenever x minus 2 whole cube is there, as per rule number 2, how many number of partial fractions can exist for this one? So, in general, for x minus 3, we have to write one partial fraction for x minus 3 whole square and x minus 3 whole cube. So, for x minus 2, a1 by or a by x minus 3 plus b by x minus 3 whole square plus c by x minus 3 whole cube, and these a, b and c constants are to be evaluated or determined. Then we get the partial fractions of this given problem. So, let us solve it. X square plus 5x plus 7 by x minus 3 whole cube. So, a by x minus 3 plus b by x minus 3 whole square plus c by x minus 3 whole cube. Now, these three constants we have to find out. X square plus 5x plus 7 by x minus 3 whole cube. Now, x minus 3 whole cube is the LCM. X minus 3 whole cube is divided by x minus 3, we get x minus 3 whole square multiplied with a into x minus 3 whole square plus x minus 3 whole cube is divided by x minus 3 whole square. What do we get? We get x minus 3. So, b into x minus 3 plus this is c constant only, we get it. Now, x minus 3 whole cube gets cancelled, we get therefore a into x minus 3 whole square b into x minus 3 plus c equals to x square plus 5x plus 7. Now, we have one linear factor x minus 3 or a linear polynomial. 0 of linear polynomial is, we know that 3. Let us put x is equal to 3 first. If we put x is equal to 3, this becomes 0, this becomes 0. So, c equals to 3 square plus 5 into 3 plus 7. So, 9 plus 15 plus 7. So, this is 22 plus 9, 31. So, c value is known. So, now a into x minus 3 whole square plus b into x minus 3 plus c equals to x square plus 5x plus 7. Now, equating x square coefficients on both sides. Here x square coefficient is a. So, a equals to, here x square coefficient 1. So, a equals to 1, we get it. Equating x coefficient on both sides. See, x coefficient means in this x minus 3 whole square also we get x term, that is x minus 3 whole square means x here 6x, but minus 6x, minus 6 multiplied by a minus 6a, but here x coefficient is actually b plus b equals to, this side is 5. Already we know a value, substitute here. Since a equals to 1, minus 6 plus b equals to 5. Now, b equals to 5 plus 6, which equals to 11. So, b equals to 11. Now, we know a value, B value and we know C value also, that is 31. Replacing A value here, B value, C value, we can find out the partial fractions of this problem. So, therefore, x square plus 5x plus 7 by x minus 3 whole cube equals to A means 1 by x minus 3 plus B means 11. So, we get 11 by x minus 3 whole square. C means 31 plus 31 by x minus 3 whole cube. So, 3 partial fractions can exist for this problem. But is there any other method? Yes, we have other method also, because here we have only one linear factor that is repeated for 3 times. So, that is why put x minus 3 is equal to y, change this one in terms of y, just split the terms, you will get the partial fractions. After that, y is equal to replace x minus 3, you get the same answer itself only. That is the second method. If you are interested, you can adopt that method also.